Welcome Algebra 1 students to another Regents review video. This is the January 2015 Regents exam for Algebra 1 Common Core. These are going to be the solutions for Part 1, questions 13 through 24, once again, of the January 2015 exam. Alright, just a couple things before we begin. Please do not, under any circumstances, use this video to get your homework done. You have to try the problems on your own in order to do well on the Regents exam, or else you don't know what you can and cannot get right or wrong or whatever it is. So please make sure that you just attempt the problems, and if you need help, then you come find me. And if you're here to check your answers, or if you need a little assistance, not much, but a little assistance, just because you don't know some of the problems, you've come to the right place. Hit that subscribe button down below and make sure that you visit my website at www.nysmathreadingsprep.com. And without further ado, let's get started. We're going to jump right to number 13. No, I'm sorry. One more thing. I use the TI Inspire CX calculator just in case you want to purchase it. You can purchase it on my website, but it's the link to Amazon, so I don't make any money off of it, I promise you. Okay, so here we go. Question number 13 of this exam. Let's get started. So Connor wants to attend the town carnival. The price of admission to the carnival is $4.50, and each ride costs an additional 79 cents. If he could spend at most $16 at the carnival, which inequality can be used to solve for R, the number of rides Connor could go on, and what is the maximum number of rides he can go on? Okay, so there's two concepts going on here. One, can you determine what the inequality is? And two, can you figure out and solve the inequality to see how many rides that he can ride? So here's what's going on. The admission price is $4.50. So basically what that means is when you go up to the ticket booth and the ticket person says, okay, I need $4.50 from you. Okay, great. So you give them $4.50. And that's your price to get into the park. So if you look at your answer choices, $4.50 should be alone. It should be just a constant. So if you're looking at choices 1 and 2, your R values are next to the $4.50, huh? That makes no sense. The $4.50 has to be alone. The 79 cents has to be next to or multiplied by the R, because it's 79 cents per additional attraction that he goes on. So we're looking for one of these answers right here. Okay? So now what we're going to do is we're actually going to solve this inequality. So if we take $4.50 plus 79 cents times the amount of rides he can go on and set it less than or equal to $16, let's just go ahead and solve it. So subtract the $4.50 on both sides, right? We get 0.79R is less than or equal to $11.50. Now we're going to divide by 0.79 on both sides. R is less than or equal to 14.5569. That is what R gives you. Now, is it 14 or 15 rides? It has to be 14 rides. You are not allowed to round up. And I know that people say, what are you talking about, Trevor? It's 0.5. Can't you round up? No, because that means that he has to dip into his own wallet and pull out some more cash to toss at the ride operator and say, yo, I want to go on this ride. But 14.5, he could only ride 14 rides. He doesn't have enough funds to ride the full 15. So that's why it's going to be choice 3. Okay, moving on to question 14. Okay, I can't even pronounce it. Oh, God. Why can't I pronounce this name? Kareen? Yeah, Kareen. Okay. I'm sorry if I butcher that name. I don't know names. All right, Kareen is planning a beach vacation in July and is analyzing the daily high temperatures for her potential destination. She would like to choose a destination with a high median temperature. Okay, so high median temperature and a small interquartile range. She constructed box plots shown in the diagram below. Which destination has a median temperature above 80 degrees and the smallest interquartile range? So the one thing that you need to know about a box and whisker plot, or just a box plot, is that the middle line in the box is your median. Okay? So if we're looking here, 80 is right here. 80 is right here. Now, we can get rid of Ocean Beach and serene shores. We are now into Whispering Palms or Pelican Beach. We're looking for now the smallest interquartile range. Remember what the interquartile range is, the IQR. The interquartile range is the third quartile minus the first quartile. So you're looking really for the smallest box, and the only one that shows that is going to be Pelican Beach, which is going to be choice 4. All right, and that is how you do question number 14. Moving on to question 15. Here we go. Some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y equals 5,000 times 0.98 raised to the x represents the value y of one account that was left inactive for a period of x years. What is the y-intercept of this equation, and what does it represent? So here's the thing. If you actually graph this, you could easily figure out the y-intercept. But if you know what this equation is saying in the first place, you should be able to get it right. Let me talk about this. Y is equal to 5,000 times 0.98 raised to the x power. That 5,000 is your principal, also known as your initial amount. Okay? So when we're talking about the $5,000, that is the amount of money that was put into the account at time t equals 0. So when these people first opened the bank account, they said, all right, bank, here's $5,000. And then all of a sudden they just abandoned it. So now the bank is charging them money to keep the account in the first place. So your y-intercept has to be $5,000 and it is representing the amount of money that was inputted into the bank at time t equals 0, or the initial amount. So that's why it's going to be choice 3, 5,000, and the amount of money in the account initially. All right, and that's why it's going to be choice 3. Moving on. 16. The equation for the volume of a cylinder is volume equals pi r squared times h. The positive value of r in terms of h and v is what? So we need to solve for r. Okay, so let's go ahead and do that now. Volume is equal to pi r squared times the height. Cool. I'm going to divide by pi and h on both sides in order to isolate r. So pi cancels, h cancel. So now we get v over pi h is equal to r squared. Now in order to solve for r, you just take the square root of both sides, and then you get, and then you get r is equal to plus minus the square root of v over pi h. They are asking you for the positive value, so it's just the square root of v over pi h, which is going to be choice 1. All right, simple so far? I hope so. Moving on. Which equation has the same solutions as x squared plus 6x minus 7 is equal to 0? So just by looking at the answer choices, I'm a little concerned because that doesn't look factorable. But let's just try it anyway. Let's see if we can factor this. X squared plus 6x minus 7 is equal to 0. What adds to 6 and multiplies to give you negative 7? I can't think of any two numbers that multiply to give you positive 6 and multiply to give you negative 7. So what that means is we need to do completing the square. And completing the square, we need to remember take the b term, have it, and then square it. So we get x squared plus 6x plus some number, and that number is in place to create a perfect square trinomial, is equal to, now I'm going to move this 7 over, 7 plus something. So now I'm going to take half the middle, which is 6 divided by 2, and you square it. That's going to be 9. So this is 9 and 9. Okay, let's keep going. Now we could factor this. What adds to 6 and multiplies to give you 9? Well, that's going to be x plus 3 is equal to 9 plus 7, which is going to be 16. Now from here, x plus 3 can be written as x plus 3 quantity squared is equal to the value of 16. And that is your answer, and that is going to be choice 4. That is a correct answer for number 17 by completing the square. All right, moving on. 18, two functions, y equals the absolute value of x minus 3 and 3x plus 3y equals 27 are graphed on the same set of axes. Which statement is true about the solution to the system of equations? So let's go ahead and graph this in your graphing calculator. I'm going to open up a new graph page. Now, in order to graph an absolute value function, you go to the button next to the catalog or the book, and you click on this button right here. It's in the middle row, the first column. All Right, click on that. I'm going to now type in x minus 3, and I get that. Now I'm going to graph the line. Now, the problem is the line is not in y equals mx plus b form. But what's nice about this calculator is if you actually go to Menu, Graph Entry Edit, Relation, you could actually type in 3x plus 3y is equal to 27. And then you press Enter. So we definitely know that these graphs intersect at that point right there. So what I'm going to do is I'm going to do Menu, Analyze Graph, Intersection Point, and I'm going to click, click. So the intersection point we know for sure is 6, 3. Okay, let's talk about this. 3, 0 is the solution to the system. No. 9, 0 is the solution to the system. No. 6, 3 is the solution to the system because it satisfies both equations. Yeah. Awesome. And I don't know why I don't know where they're getting these points from. I think that what they're trying to do is they're trying to trick you because, look, this line here, this line only touches this absolute value function at one point. These lines are parallel, so there's only one intersection point. I don't know where they're getting that stuff from. So the answer has to be choice 3. Okay, moving on. 19. Miriam and Jessica are growing bacteria in a laboratory. Miriam uses the growth function f of t equals n raised to the 2t, while Jessica uses the function g of t equals n to the 4t, where n represents the initial number of bacteria and t is the time in hours. If Miriam starts with 16 bacteria, how many bacteria should Jessica start with to achieve the same growth over time? Okay, so here's what I'm going to say. I'm going to let n equal the initial number, meaning the initial number in this case has to be 16. So we'll talk about that in a second. Now, I'm going to write down Miriam's function. Miriam is f of t. Miriam is f of t is equal to n raised to the 2t power. Okay? So what that means is Miriam starts with 16 bacteria. So that means that her function really is f of t is equal to 16 raised to the 2t power. Keep that in the back of your head for a moment. Now we're going to talk about Jessica's function. I'm going to put Jessica over here. Jessica. Okay? Now, Jessica's function is g of t is equal to n raised to the 4t power. Now, the problem with this question is we don't know what the n value is for Jessica. But what we can do is we could actually manipulate her equation to make it look like Miriam's. You see how Miriam's is n raised to the 2t? Is it possible to make n raised to the 4t look like n raised to the 2t? Yeah, of course we can. We could say this. We could say g of t is equal to n squared raised to the 2t power. Why? Well, because you should know your laws of exponents. This right here is called the power-to-power rule. Basically, you can multiply these two exponents. 2 times 2t gives you a result of 4t. It's just another way to express it. That's perfectly fine. We could do that in mathematics. We could rearrange things. Now look, n squared. Well, if we know that your n value is 16, what does the n squared value equal? Well, let's figure it out right now. N squared is equal to 16. Now that 16 is coming from Miriam's initial amount. Take the square root of both sides and you get n is equal to the number 4. So Jessica's initial amount to achieve the same growth has to be 4 because g of t is equal to 4 quantities squared. Oops, sorry. That parentheses shouldn't be there. 4 squared. I did it again. Shoot. My apologies. 4 squared raised to the 2t power. Isn't that the same thing as 16 raised to the 2t power? And isn't that the same thing as Miriam's function? Right up here? Yeah, they match. So therefore, your answer is going to be choice 4. That is the initial amount that Jessica has to use to achieve the same growth rate. All right. That was definitely a trickier question. Not going to lie. Let's go ahead and try number 20. If a sequence is defined recursively by f of 0 equals 2 and f of n plus 1 equals negative 2 f of n plus 3, for n is greater than or equal to 0, then f of 2 is equal to what? So, we're going to find f of 2. But in order to find f of 2, we're actually going to use f of 1. And I hope that makes sense. So watch this. The problem is we don't have f of 1, we have f of 0. If I go to my function, which is f of n plus 1 is equal to negative 2f of n plus 3. Watch what's going to happen. I'm going to plug in 0 for n. Watch this. Recursion means to use the term before to get your next term. So that means we have f of 1 now. F of 1 is equal to negative 2. But what is f of 0? F of 0 is 2. So we get 2 plus 3. So we get f of 1. F of 1 is equal to negative 4 plus 3, which is equal to negative 1. So f of 1 is equal to negative 1. What I am then going to do is I'm going to use that to generate my next term. So now what we have here is we're going to generate f of 2. So f, now if I want 2, I need 1 plus 1. So I need f of 1 plus 1 is equal to negative 2 f of 1 plus 3. Okay? Now this does give you f of 2. F of 2 is equal to negative 2. Well, what's f of 1? It's negative 1 plus 3. F of 2 is equal to 2 plus 3. So f of 2 is equal to the number 5. And that is going to be your answer, which is choice 3. So far, so good? All right. Moving along. Number 21. An astronaut drops a rock off the edge of a cliff on the moon. How is that even possible? There's no gravity in space. I don't know. The distance d of t in meters the rock travels after t seconds can be modeled by the function d of t equals 0.8 t squared. What is the average speed in meters per second of the rock between 5 and 10 seconds after it was dropped? Ladies and gentlemen, average speed means slope. Slope. So that is your, now remember, your change in y over the change in x, which is y2 minus y1 over x2 minus x1. Now, we need to find the y value when t is equal to 5 and when d is equal to 10. So what we're going to do here is this. We're going to input d of 5. So we get 0.8 times 5 squared. That equals 20 when you plug that into your calculator. Now, d of 10 is equal to 0.8 times 10 squared, which is then equal to the number 80. So these are your y values. Now we're ready to start the slope formula. So here we go. Change in y over change in x is equal to 80 minus 20 over 10 minus 5. That is equal to 60 over 5, which is equal to 12 meters per second. And that is going to be choice 1. That is the slope between those 2 points. Alrighty, moving along. 22. When factored completely, the expression p raised to the 4th minus 81 is equivalent to what? So p to the 4th minus 81, I hope that you could realize and just see it, that this is by the difference of 2 perfect squares. So when you factor this by the difference of 2 perfect squares, you get p squared plus 9, p squared minus 9. Now, when it says factored completely, obviously there's going to be more than one step. This thing right here, that p squared minus 9, can be factored again by the difference of 2 perfect squares. That's dots again. So we get p squared plus 9 followed by p plus 3, p minus 3. And that is going to be choice 3. If you try to factor p squared minus 9 by dots and you got choice 4 as the trick answer, that is wrong, because you cannot factor this by dots, as that is an addition sign, not a subtraction sign. All right, 23. In 2013, the United States Postal Service charged 46 cents to mail a letter weighing up to 1 ounce and 20 cents per ounce for each additional ounce. Which function would determine the cost in dollars of mailing a letter weighing z ounces where z is an integer greater than 1? Okay, so you need to know that Now, again, it goes back to what we talked about with the ride situation. What was that, question number 14, 13, or something like that? 46 cents. So you go to the post office. You say, all right, mail person, here's my letter. Okay, you need to owe me 46 cents right now to mail that letter. Okay, no problem. So here's 46 cents. So then all of a sudden they weigh it and like, uh-oh, Trevor, I'm sorry. It's a couple ounces over the weight limit. You got to pay a little extra. So I need to pay 46 cents first. So that is why it's going to be either choice 2 or 4. 46 cents is not multiplied by the letter Z. That makes no sense. It's 46 cents when you walk into the store. And then it's 20 cents per additional ounce. But is it going to be choice 2 or 4? And the difference is here. Z and Z minus 1. And you need to read very carefully. Z is an integer greater than 1. The first ounce is 46 cents. Each additional ounce is 20 cents. But when you talk about ounces and how much it costs, you need to take into account that the first ounce was already paid for. Your answer is going to be choice 4. Okay? Because choice 2 is suggesting that you owe 46 cents and you owe 20 cents for the first ounce. No, you owe 46 cents for the first ounce and then followed by 20 cents for each additional ounce. So you need to take away that 1 value. So that's why it is going to be choice 4. All right? And number 24, last but not least. A polynomial function contains the factors x, x minus 2, and x plus 5, which graphs or graph show below could represent the graph of this function. So if the factors are x, x minus 2, and x plus 5, your roots, or where the function crosses the x-axis, is x equals 0, x equals 2, x equals negative 5. So that's why it is going to be choice 1, because this is x equals 2, this is x equals 0, this is x equals negative 5. Choice 2 makes no, well, this answer makes no sense, and this one they just tried to fool you with the factors being the same number. But remember, when you have the factors, the roots are the opposite values. And that is the conclusion of this video. Make sure that you hit that subscribe button down below, and make sure that you visit my website at www.nysmathreaderspep.com for many more math material and more things in Algebra 1 and geometry and trig and all throughout mathematics. And I hope to see you soon.